So long division in algebra becomes very important in leaving cert when you're trying to solve single variable polynomials. So all this means, single variable means there's only one variable. So these are all x's. There's no x and y together or anything like that, all one variable. And polynomial just means there's more than one term. So it could have three terms and it would be a quadratic, or it could have five terms and it would be a quartic. So there's a few different methods that we can use. This one is called the standard long division, or sometimes called the bus stop, because this here looks a little bit like a bus shelter. Then we have the area model, or some people call the box method. And the third one that I would use is synthetic division. Now, before you use any of these methods, it's really important that you check a few things. So some things to notice: if you look at the powers on the x's, so this is x to the power of 3, and then x to the power of 2, and then x, and there's this little hidden 1 there, x to the power of 1, and then the constant, or the one with no x's, and there's actually even a sneaky little x to the power of 0 there. So this is in descending powers of x, meaning the powers are going down in order. It's really important that both of these are in descending powers of x. So in this example, it looks like it's a quadratic, which is x to the power of 2 is the highest power, but there's an x to the power of 3 over here. So before we use any division method, we should put it in the correct order. So starting with the highest power, 3x to the power of 3, we'll work down through the powers. So the next highest power is the x squared. So we'll put in this 13x squared, and make sure to separate it with either a plus or a minus, depending if it's positive or negative. Then the next highest power is this x, or x to the power of 1. So we'll put that next, negative 18x. And lastly, we have the constant, negative 40. And over here, this is already in order, x to the power of 1, and then x to the power of 0, or in other words, the constant. So now we have it in the correct order. Finally, you might see some examples like this, where this looks like it's in the correct order because we've got x to the power of 3, and then x to the power of 1, and then the constant. So it's in the right order. But it is missing its x squared term. So because it's starting with x to the power of 3, we have to have an x to the power of 2, an x to the power of 1, and an x to the power of 0, or a constant. If it started with x to the power of 5, you would have to have a power of 5, power of 4, power of 3, power of 2, power of 1, and a constant. So in this case, let's start with our highest power first anyway, 36x cubed. Now we need an x squared term, that's the next highest power. But there's no x squared term here, so what number represents nothing will be 0, so there's no x squareds. Next we have our x term, minus 28x, and lastly the constant. And just check over here as well, that's already in order, so we can just write that down as it is. So before you start doing any algebraic division, no matter which method you use, you should double check that they are in the correct order in descending powers of x.